Students, this is a short video on composition of functions or composite of functions. Let's start with the definition. Given two functions f of x and g of x, the composition of those two functions can be defined as follows. F composite g of x, that's a letter O, it's not multiplication, it's just a letter O. F composite g of x equals f of g of x. Likewise, g composite f of x equals g of f of x. Notice that we are not multiplying the functions. What we are doing is evaluating one function inside the other. So this is why they have different hierarchies. In this case, on the first example, f will be your quote-unquote outside function, g the inside function. In the g of f of x, now g will be the primary of the outside function, f is the inside function. In other words, f will go inside g will go inside f, in this case. F composite g, or very casually fog of x, g of x. We say g of f or f of g of x. Let's go ahead and do a couple of examples. However, before we do examples, let's just go back to basics. If I ask you to give any function f of x equals, very simple, 4x minus 7, evaluate f of 0. When the input is 0, how much is the function? How much is the output? Well, no big deal. What we do is we replace the x by the input 0. 4 times 0, 0 minus 7 will be negative 7. Meaning that when the input is 0, comma, the output will be negative 7. We can write it as an ordered pair, x, comma, y, or x, comma, f of x. F of 1, we do same thing. In this case, the input is 1. 4 times 1, 4 minus 7, that will be, of course, negative 3. F of negative 2, nothing special, same old. We replace, wherever we find the x, we place the negative 2. So we evaluate the function when x, the input, equals negative 2. 4 times negative 2, negative 8 minus 7, negative 1, 5, 15. Oh, now we don't have a number, we have just a variable a. No big deal. Do I need to do anything different? Not really. Wherever we have the x, we plug in the a. So it will be 4 times input minus 7. 4 times a minus 7, in this case would be 4a minus 7. If they were to ask us to find f of x, 3x plus 8, we do the same thing. The functions are very simple. It will be 4 times input minus 7, 4 times input, which is this guy, minus 7. So we place here 3x plus 8. So we evaluated f with the input 3x plus 8. In this case, we just have to do distribute the 4. 4 times x, 12x, plus, that will be 32, minus 7, 12x, what's that, 2 plus 25, I believe. And so from there, that will be the answer. F of 3x plus 8. Okay, so this is exactly, if you know this, you're already experts. We just did a fog problem right here. We don't even know we were doing that. So let's go ahead and do a couple of examples. So example number 1, let's keep it easy. Examples. Number 1, let me try actually problem number. Let me just go easy. Let's just do problem number 1 from your book. F of x equals 2x minus 3. G of x equals 6 minus 4x. Okay. They ask us to find the fog of x, so f of g of x, and the GOF, g of f of x, which is g of f of x. The first part, we need to do, we need to look for the first part, we need to look for G will be the inside function, so G goes inside F. In the second example, in the GOF, F will be the inside function, so F gets inside G. Okay, so let's see what we have. Yeah, let's see what we have. This was the marker. Okay. Anyway. Oh boy, I'm losing my mind. So we have F will be the outside function. Oops. What does the outside function state? F is 2 times the input minus 3. Let's see. Functions are very straightforward, not to say stupid. So whenever the input comes in, we multiply by 2, subtract 3. The input comes in, we multiply by 2, subtract 3. But what is the input in this case? The input will be the G. So this guy goes here. That will be 6 minus 4x. And let's see, that's the actual composite. Now we just have to do some algebra. 2 times 6, that will be 12. 2 times negative 4 minus 8x minus 3. Let me just write here on the side, that will be negative 8x, 12 minus 3, plus 9, and we are done. Okay, let's go ahead and find the GOF, or G of f of x. Now G is my outside function. This looks like an 8. G is my outside function, and F is the inside function. So F goes inside G. Okay, so now the G is the dominant. The G function says 6 minus 4 times the input. 6 minus 4 times the input. However, in this case, what is my input? F of x. So this jump to x minus 3 goes inside G. It will be 6 minus 4 times 2x minus 3. And we just distribute it accordingly. So it will be 6. Negative 4 times 2 will be negative 8x. Negative 4 minus 3 plus 12. By like term, that will be negative 8x, 6 plus 12 plus 18, and we are done. Don't even attempt to equal it to 0 to solve for x. No, that's it, you're done. You found the G of f of x. The inside function goes literally inside the outside function. Let's try a second example. In this case, it says f of x equals 4x plus 3. In other words, when the input comes in, multiply by 4 and then add 3. No big deal. G of x, 2x squared minus 5. Something needs a bit more involved. When the input comes in, first we need to square it. Then we multiply by 2, then we take 5 away. So let's go ahead and find the fog and the GOF. So f of G of x, by definition, is f of G of x. My f is my outside function. F is 4 times input plus 3. 4 times input plus 3. But in this case, what is the input? It will be G of x. So here we put 2x squared minus 5. And that's the actual composition function. 2x squared minus 5. And it was, there you go. So now we just have to multiply the 4 and combine like terms. 4 times 2x squared, 8x squared. 4 times negative 5 minus 20 plus 3. That's it will be 8x squared minus 17, and we are done. Let's go ahead and find the GOF, G of f of x, G of x. Now my G function here is when the input comes in, first square multiplied by 2, subtract 5. So 2 times input square minus 5. Okay, but what is the input? In this case, the input will be now f of x. That will be 4x plus 3. We have two operations, exponent and multiplication. If you heard, of course, exponents go first, so it's going to be 2 times minus 5. When I expand this guy, that will be 16x squared. 16 squared plus 24x plus 9 minus 5. Okay, you can verify this multiplication when you FOIL. What is it here? 24. Now we need to multiply by 2. 2 times 16, 32x squared plus 48x plus 18 minus 5. Combining like terms, this is the only two that we need to combine. I'm going to be lazy here. 18 minus 5, that will be 13. And we are. Let's try one more example. Here we have f of x equals 2x plus 6, g of x, x minus 6 over 2. We need to look for the f composite g of x and g composite f of x. So g composite, f composite g goes inside f. My f function will be 2 times input plus 6. But of course, we already know what is the input, g, so we place here x minus 6 over 2. When I simplify this one, notice that 2 over 2 equals 1. So now what do I have? X minus 6 over 1, it's just that, plus 6, and this guy will be x. Okay, so we found a pair of fractions that when we do the composite on them, f of g and g of f, the answer equals x when we do the FOG. Let's see what happens when we do the GOF. Hopefully we get the same answer, x. So now this is going to be g is the outside, the dominant function is going to be input minus 6 over 2. So input minus 6 over 2. So instead of x, this is where we put the input. What is the input? F of x. So we place here 2x plus 6. Last time we checked 6 minus 6 is 0. So we have 2x over 2, and this guy equals to x. All right, so now we can definitely say it. We found two functions when we do the composite f of g and composite g of f. Both functions equals to x. We'll discuss that in a few. Okay, so that's it. This is when we need to find, well, let me just do another one. What if we have, just looking at the homework, there's nothing much to do here. Let's see what we have. Okay, let's try, let's try this other one. Example number 3, f of x equals the cube root of x minus 2 plus 2, g of x equals x cubed minus 2. Let's find the FOG. This case f is the dominant, so the f function is the cube root of x plus 2. This is where the x goes. However, what's the input? G of x. So now instead of x, we're going to replace x by x cubed minus 2. Okay, last time we checked, of course, negative 2 plus 2, that is 0. So we have the cube root of x cubed, which is equals to x. Let's go ahead and find g of f of x. This is g of f of x, of course. The g is the outside dominant function. The g function is the input. Let's go ahead and cube and take 2 away. Well, what is my input? F of x, which is this cube root. So cube root of what? X. plus 2 cube minus 2. Cube and x, the cube and the cube root bye-bye. So we have x plus 2 minus 2 equals x. Once again, just like in the previous example, we found a pair of functions that when we do the composite, between them, the answer both were x. Not just any answer, same answer, and both of them x. So just hang in there. Sometimes, folks, we don't have to provide the full equation. Sometimes we just simply need to track down one particular number. For example, if they say f of x equals I don't know, 3 over x, and g of x equals 2x squared plus 3, find f of g of 0. Find f of g of what? Of 5. Okay. Let's go ahead and find g of f of 1 and g of f of -3. F of g of 0 will be f of some number. Now, what does it mean? Notice that in this case, we have one input, in particular, x equals 0. Where am I going to plug in the 0? Plug the 0 into g. When the input comes in, which is 0, the output will be blank. Okay, we just need to substitute 0 or evaluate g when x equals 0. That result, we plug it into f. So we go from the inside out. So let's go ahead and first plug in the 0 into g. Let's see if we can do this mentally. When x equals 0, 0 squared is 0 times 2 is 2 plus 3 equals 3. So now we're looking for f of 3. But here 3 over 3 will be 1. And we are done. That's all we need to do. Very hard to graph, I mean, to write everything. But this is in general what we did. When the 0 input came in, the output was 3. Why is that? Because the 0 went through the g transformation. We took the 0 squared times 2 plus 3, so the output was 3. Now that output, the output of g, became the input of f. Once we plugged in the 3 into f, 3 over 3 equals 1. Yes, so first we went through the g function and then to the f function. Notice that the output of one function becomes the input of the other. So the output of g becomes the input of f. Now what does the composition do? Just going straight here without going step by step. Anyway, that's what we have so far. Let's go ahead and find f of g of 5. Notice that 5 goes inside g, so we're looking for f of something. What happens when x equals 5 in g here? 5 squared, 25, times 2, 50, plus 3, 53, 5, 3. I forgot that we wanted that by 2. So now the output of g, when the input is 5, the output will be 53. And where do we plug in this number? Into the f. So that would be 3 over 53, and we are done. So what do we have here? The 5 went into g and brought back an answer 53. We plug in the 53 into f, and the answer will be 3 over 53. And that will be it. Let's try one of these two, maybe a g of f of 1. Now the paper, the rows are reversed. This would be G of, okay, G of something. What do we do here? Let's do write it like this. For example, this example would be G of F of 1. Wait a minute. So I gave you the definition already. So now what do we need to do with the 1? That 1 goes into F. So 3 over 1, that would be 3. And that output goes back to G, so goes here. It's going to be, just do the hand, 2 times input square plus 3. What is the input? 3. 3 times 3, 9 times 2, 18 plus 3, 21. And that will be it. So what do we have here? We simply started with the input 1. The 1 took a trip and went to F. And after F got tired of 1, so just get out of here. And F sends 1 out with the number 3. So now this 3, we need to input it into G. And G had more fun in her place. And the answer was 21, I hope. Like where? The square 9 has 18 plus 3, 21. Voila. And the last one, maybe I'll leave it to you to do it. However, I'm going to answer it here. If negative 3, it will be G of -1, which is 5. I got 5. When the input is -3, goes into G. Into F, sorry, into F. So when the x equals -3, 3 divided by -3, that will be -1. That -1, the output of F goes to the input of G. So when x equals -1, -1 squared is 1 times 2, 2 plus 5, 2 plus 3, 5. And we are done. So this last one, what did we do? The -3 provided -1, and the -1 gave me 5. Well, we went through the F rule here and the G rule on the second one. Okay, so that's it, trying to find the F of G or G of F of a particular number, not just the function as we did it before.